Hello, I hope you are well. In this video we will see, can a neutrino be created in a laboratory? Welcome to the question answer channel, the channel where you will find the answer to everything. Thanks to Adam Jacholkowski, Joshua Engel, Jonathan Hardis and Ray Stefanski for sharing their views with us. Let's go for Adam Jacholkowski's first answer.
Not really created but produced from weak decays of unstable particles. At CERN, even a beam of neutrinos was produced in order to send them to a remote, about 700 km away, Gran Sasso laboratory. CERN neutrinos to Gran Sasso, Wikipedia. CERN neutrinos to Gran Sasso underground structures. The CERN neutrinos to Gran Sasso (CNGS) project was a physics project of the European Organization for Nuclear Research (CERN). The aim of the project was to analyze the hypothesis of neutrino oscillation by directing a beam of neutrinos from CERN's facilities to the detector of the OPERA experiment at the Gran Sasso National Laboratory (INGS), located in the Gran Sasso mountain in Italy. The CNGS facility was housed in a tunnel which diverged from one of the SPSLHC transfer tunnels, at the Franco-Swiss border near Geneva. It used the super-proton synchrotron (SPS) accelerator as a source of high-energy protons. History. Approval for the CNGS project was signed by the CERN Council in December 1999. With civil engineering on the project starting the following September. Construction of the tunnels and service caverns was completed in mid-2004, with equipment installation completed in summer 2005 and commissioning being carried out throughout spring 2006. The first proton beam was sent to the target on the 11th of July 2006, with the CNGS facility being approved for physics operations on the 18th of August 2006. CNGS ceased operation in 2012. The tunnel was then repurposed for the Awake experiment, which became operational in 2016. Function. A proton beam was taken from the SPS at 400 GeV and is made to collide with a graphite target within the CNGS tunnel. The resulting particles, most importantly kaons and pions among many other particles, were then focused by magnetic lensing and traveled 1 km (0.62 miles) down the CNGS tunnel in a vacuum tube. These particles are naturally unstable, and their decay products include muons and muon neutrinos. All particles except neutrinos, protons, muons, pion, kaon, stop near the end of the tunnel. The neutrinos continue their flight unaffected, as they rarely interact with matter. The number of muons was measured at this point, which gave an indication of the beam's profile and intensity. This beam then passed 732 km (455 miles) through the crust of the Earth, and it is expected that during flight some of the muon neutrinos convert into other neutrino types such as tau neutrinos. Once the beam arrived at Gran Sasso, the OPERA and Icarus experiments were used to detect the neutrinos. Results. The first candidates for neutrino oscillation to tau neutrinos were announced in May 2010 by the OPERA experiment. In total 5 tau neutrinos were observed, 5 consistent with the expectations from the theory of neutrino oscillation. On the 22nd of September 2011, the OPERA collaboration garnered international attention when they released a preprint 6 reporting the faster-than-light neutrino anomaly, wherein neutrinos were measured to be traveling, on average, at faster-than-light speed. On the 24th of February 2012, the team said they had discovered 2 problems with their previous test, muddying the validity of the previous result.
The next answer is from Joshua Engel.
You can make a neutrino in your kitchen. Potassium decays via beta decay, which emits a neutrino. Bananas are famously good at providing potassium, including a small but measurable proportion of radioactive potassium. So your lunch could be emitting neutrinos as we speak. Note that eating a banana exposes you to about 1% of the other radiation you get from all of the other sources in your daily life. And the neutrinos, of course, escape right through your body without touching it in the least.
The next answer is from Jonathan Hardis.
Can a neutrino be created in a laboratory? Yes, they are created at accelerator facilities such as Fermilab and CERN. They are also created in quantity at nuclear reactors, such as those used to generate electricity.
We continue with Ray Stefanski's answer.
Can neutrinos pass through other neutrinos? Photons can pass through each other, that's why our eyes can clearly see objects. If photons bounced off each other, we wouldn't see anything. Generally, bosons, that is force carriers, can pass through each other without interacting. Neutrinos are fermions, more like electrons and quarks. They obey the Pauli exclusion principle. No 2 fermions can occupy the same space at the same time. If 2 neutrinos converged on the same point at once, they would interact just like any other fermion. However, this assumes that neutrinos are Dirac particles, that is, that there exists an anti-neutrino. But Majorana neutrinos, like photons, would be their own antiparticles. Whether the neutrino is a Dirac or Majorana particle isn't known. However, in either case, the neutrino is still a spin 1/2 fermion, and therefore they would interact and not pass through one another.
This is the end of the video. Thank you for staying until the end. I hope the video has you more. If so, you can subscribe and activate the bell to miss any video. Also remember to leave a like. We are coming to the end of this video. You can continue the debate on this question in the comments with the community. See you soon.